So my information, I'm Michael Labriola. I'm a senior consultant at Digital Primates. We build applications, video players. As far as our clients go, the way we usually like to put it is that if there's been a video player, a custom video player that's come out, like a high-profile one in the market in the last year, there's a 50-50 chance we had our hands on it in some way. We do a lot of custom video players for a lot of people. That's part of what we're known for, that and doing a lot of big enterprise applications. So I've been developing internet applications for about 17 years. I've authored 5 books myself, Jeff's done 12, and we became partners in this in about 2007 with our organization. So today, what we're going to do is kind of walk through a little bit of this. I won't bore you too much with the whole video and the internet today, but the idea is understanding why this is important, diving into Dash a little bit, what we're doing, the choices we made along the ways, the challenges, and then talking a little bit about what we did, actually a lot of it about what we did, and then sort of painting a picture of the future of how this can all go and what we're trying to do here, and what we're trying to accomplish. So, that said, video, internet, everyone's seen this, or some variation of this slide, right? But the important part is that video makes up 50% of the traffic at peak periods. That's a really, really relevant thing. It's really important. And one of the reasons that that's so very important to me is that I'm kind of an internet standards guy. I kind of care about, I have, let's call it some form of like personified empathy for the internet. I want the internet to function well. I want it to be able to work well. And the thing is that the way we stream a lot of video traffic today, in my opinion, is not only not great for the internet, but it's sort of against the way that we evolved. We evolved in this world of internet traffic, of having this sort of APIs that were about making quick requests and responses to us. Our web servers, our infrastructure is optimized around the idea of being able to get a packet somewhere, well, not a packet, but get a fair amount of information somewhere in a very short period of time, but have them being singular requests. We've layered a lot on top of that to do interesting things, but in the course of actually layering a lot on top of it, we've become more persistent in connections, we've added layers, we've sort of overloaded some of the infrastructure that we originally intended. And in doing this, when we're talking about now 50% of the traffic in peak times, it means that if we continue and we continue to push this way, either we need to fundamentally redefine a bit of how routing and internet stuff works to continue this sort of growth, or we have to make some different decisions. And that's part of what this is all about, what we're actually trying to do. See, in the Dash world, we're talking about adaptive streaming. And adaptive streaming is really interesting in the sense of a couple things. First of all, it puts a bit more onus on the client than it does on the server. In an adaptive streaming metaphor, it's up to the client to be able to go and retrieve the next bytes, to be able to get the next part of the segments, the next fragments that it needs down from the server. It's a client-based decision. And to me, in our world now where most of our client processors are actually pretty rich, by the way, background, I'm an embedded guy, so I actually think like modern phones and stuff are incredibly amazing in the amount of technology that we have in that small little package. But we've got big client engines to be able to do this work. We can go off, we can do, and we can make some of these decisions. And in doing so, in being able to make more of these decisions at the client, we begin to be able to use the infrastructure of the web in sort of the way that it was originally defined, and sort of the original idea behind HTTP, which is that we can make requests, repeated requests for small amounts of information, grab that information. All right, I'll put it up here, but it's the, all right. I slowly moved it down over time. It's come back up now. All right, here we go. So in the course of doing this and going back to the client, we can begin to use the infrastructure of the web in the way that it was originally intended again. We can begin to make things about requests, about making a request for a given piece of information. And why is that important? Well, we've gone through and we've defined all this infrastructure of origin servers and these sorts of things in order to replicate information out, in order to move information out to multiple points where we can see them. But the thing is that the web actually has really good infrastructure for doing those things to begin with. A web server is actually quite adept at being able to make and answer multiple requests. A single Apache server running by itself, if we're talking about small requests that are individual pieces that are returned to it and not large persistent connections that need to be kept open, can handle an enormous volume. We have things like caching mechanisms built into every browser. We have proxies that can actually cache information. And all of these things are actually very, very interesting in the sense that we have multiple layers of caching built into the infrastructure of the web already if we properly use it. And what I mean by properly use it here is when we go and get a file from a web server in a single file, that file can be cached at multiple points. GET requests can be cached. They can be pulled in. It's much the philosophy behind REST or any of these other things. So what we're looking at with adaptive streaming, one of the many reasons that I'm very excited about is we begin to use the infrastructure of the web again. Okay? And the idea here is that we put the onus on the client to some degree for managing that stream, but as we'll talk about, this actually gives us a whole lot of capability when we get down a little bit later and making some really good decisions. All right, that said, in the streaming landscape right now, people that are doing it this way, we've got lots of players actually. It's more than just these three. But there's three big players. Apple's HLS, iOS only, obviously, or iOS primarily at this point. Microsoft Smooth Streaming, Adobe's Dynamic Streaming, HDS. All three of these technologies are accomplishing the basic same goal. They're putting onus on client side, they're being able to get fragments from a server, they're working this information back and forth. The big advantage, by the way, having gone back and been in video before all these things existed, or one of the big advantages, is that in the old days of video, it was actually very difficult for us to make decisions on when to switch up and down, when to go between bit rates and bandwidth. It was a very interesting and difficult thing. There was all sorts of clever solutions where people would try and download things in the background or try and figure out if we were dropping certain frames, and then if so, make a decision to switch. But the problem was we were always trying to examine the problem from outside the box, if you will. We don't know if we dropped a frame because the processor was too busy, or if we had to skip something because the network wasn't sufficient. We were making educated guesses. But in all of these, we have a really simple idea. If, when we download a fragment of video, if the bit rate at which that's supposed to play is going faster than we can actually viably download it, then we need a lower bit rate stream. All of these are successful, and all of these have gone on to be successful because of the fact that they have this main concept of the client can make this simple decision. Based on this simple decision, we can switch bit rates very fluidly at certain fragment breaks, and we're able to move between these pieces. So all of these are wonderful players, and there are more. Again, not to shortchange any other ones, it's just these are the three that are best known. Now, here's the issue. And I have to say most agree that HTTP streaming is the most efficient choice because there's never a time when everyone agrees on anything. But most people agree that HTTP streaming is really efficient. But we have different devices supporting different streaming protocols. What does that mean? That means on my computer it is entirely possible that in my nice little cache and all those caching layers I talked about, I could have the exact same data basically in several formats. I may have the exact same fragment of video in HLS or HDS. I may have it in all these different ways because there's no unified way in which we've chosen to represent these things and be able to do them. So depending on the device I came through, my iPad is going to have to hit the same video in a different way than my PC hits it. That's unfortunate because now not only is it about my machine, but the infrastructure above me, the proxy servers, the daring caching mechanisms we could have along the way, all begin to have the scenario where they can't really do their job. So having no one sort of ubiquitous standard approach actually results in inefficiencies across the board. We're serving it in several ways by several different broadcasters across a different range of devices today. We want to change that. So that's what MPEG-DASH to me is about. MPEG-DASH is about trying to change that. MPEG-DASH is about saying, hey, this idea that's been pioneered by many people is actually really good. But if we actually, instead of letting every vendor establish their own mechanism for doing it, if we actually get some input from vendors, but turn around and make it an ISO standard, or an ISO standard that we can use, then we can gain the benefits of this, but we also gain the infrastructure benefits. We gain the ability, top to bottom, of being able to use this technology across the board. Now, in order to do so, we have to address both really simple and advanced use cases, and if anything, Dash tries to maybe account for too many use cases. But what we can do here is we have really high quality distribution. We can very quickly and adaptively switch things, and we can reuse this existing content. In essence, what I really want to be able to do is I want to reuse the existing content, whether I'm going from this device, my iPad, my laptop, it doesn't matter. I want to attempt to unify a standard way in which we stream these things, because by doing so, we not only reduce the burden on the network infrastructure, but we also reduce the burden on the publishers of trying to maintain end streams and end types and end pieces of data, and then also debugging and things that go along with it. There's all these incidental charges and thoughts that don't really go into the idea when we think about having multiple streams and multiple sets of data. There's a possibility of an error in one, but unless we actually know the device that somebody happened to be addressing something from, we really can't debug easily and know why a given stream was down or where there's a problem. There's incidental things that go along with all of these, and we want to eliminate that. We want to do something different. So that's what Dash is really about. Now, Dash and codecs, Dash and formats is another way to put it really honestly, but Dash and codecs. Dash is not in the business of specifying a given format for your data or codec. In fact, we're going to talk a lot later about DASH-264, but the idea behind Dash is that Dash is really talking about how we get the data, about how we define the manifest, about how we understand what bytes are out there and when we pick them up. The idea behind this, and much like the ideas with MPEG, and in particular MPEG-4 that went through, is that existing and future codecs can work with Dash. We're not trying to prescribe a given way of encoding video. We're trying to describe a way of distributing video, a way of being able to allow, or more precisely, allowing the distribution, allowing the retrieval of video, because this is really now a client-facing sort of thing. So the Dash manifest describes for this particular stream what's being used, and what's really interesting about that is that when I can point a player to a given stream, Dash sort of defines the ability of saying what is in this stream and what must you have to play it. And the client can sort of opt out. The client can say, I don't actually understand that. I don't have a codec for that. I can't do those things. But it provides us the unified way in which we go about doing that, which we go through it. Okay, DASH-264. So H.264. It's certainly, many people have opinions on it, but it's the dominant format today. We've got a lot of people who are continuing to support enabling 264. Although there's been various toss-ups with Google and what they've said over time. Even recently, Firefox said that they plan on mobile devices of supporting 264 and going forward, and Mozilla is in general, because they're looking at this scenario now saying this is how most of the content's produced. It provides support for requirements such as DRM, and it's backed by rigorous testing and conformance. So again, if we understand that Dash doesn't care what format we're using, what codecs we're using to get there, then it's totally feasible to take 264 content and use Dash to deliver it. And to me, in the short term at least, and we're talking like probably within the next year, this is the dominant way that we'll be producing content or will be consuming content from our perspective of the things we're doing. So Dash-264 is a very, very important piece, and it's what we're going to see here and what we're doing. All right, really quickly, small aside. There's a Dash Industry Forum. There was an event last night. The Dash Industry Forum is really, 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 really relevant. If I can't get that across, it's really, really relevant. Because the thing is that we talked about starting with all these vendors who have individual formats. And in a world where we have vendors who have individual formats, we have a constant scenario where we're going to have multiple copies, multiple devices, different ways of going about it. I believe it's the MPEG-4 spec that actually says, and I like the way they say it, is that the goal is to be able to have vendors coordinate on formats but compete on implementations. This, to me, is very, very wise, in the sense that if we agree on how it goes, the competition can be about making it better and better and better on the implementation front, but we can agree on the format. It doesn't remove competition, it focuses competition in the right way. That's what Dash is trying to do too, right? And the Dash Industry Forum is trying to support that by bringing these companies together, by facilitating it, and ensuring that as network conditions change, we move forward. Now, objectives. Trying to promote and adopt the MPEG-DASH. Obviously, that's clear, right? If an industry forum wasn't going to do that, we don't know. But the point is that a lot of people don't know what Dash is about, and a lot of people don't understand why to use it. But right now, there's a big push behind this happening. Interoperability, deployment guidelines, interoperability tests, collaboration on various bodies and industry organizations. That 46 members, I have to check and see if it hasn't gone up since this slide was written. But the point is that this industry foundation is made up of a whole bunch of companies. And this is really, really relevant because these companies, including ours, which is great, but these companies include many, not all, many of the players that we said were the dominant formats today. So if we have 2/3 of the dominant formats today represented on this particular industry forum, I think it increases the chance that we actually see that environment where we're using this format, where Dash becomes a very, very real and very imperative thing. So I've got a lot of hope behind where Dash goes because of that. And the two I'm obviously pointing out here are Microsoft and Adobe, who are two of the formats that are listed up there, have already signed on, and they're prominent members of this industry forum. Okay. Let's talk about building a desktop Dash player. There's a whole lot of technologies for playing video in a modern browser. That's certainly the case. Flash, Silverlight, HTML5. This Dash player that we're showing today, the things that I'm working through and going to talk about, are focused on Flash. Why is a reasonable question, especially in the world where Flash exists today. But here's the thing. Right now, Flash has still, for video, the most reach for us. It has the most reach because it's installed and viable the most places. even on mobile devices within a certain capacity. Silverlight doesn't have that reach. HTML5 right now we have Chrome support, and that's cool that we have support for 264 in Chrome and we can do things, but we don't have a lot more than just Chrome. And that's really difficult as sort of building a ubiquitous player. So as a first starting point, we focused on Flash. The interesting thing, though, is that the way in which we're approaching this is totally viable for anything. It's viable for any place that we can actually take bytes and they can understand the format that we have them in. And we'll see that that's how it plays out when we talk about JavaScript and other versions. So the content you're going to see today is focused on a Flash player, but it's unique in the sense, or the important part is the sense that it's dealing with the Dash portion of it. All right, so a couple things about Flash players we're going on here so we can understand. The reason this all works right now is that Flash player includes a native video player. But that video accepts sources from a camera or from a net stream, okay? And that net stream supports not only streaming in FLV bytes, but it supports something that's very, very relevant for us building these types of players and that we hope to see other browsers implement as well besides Chrome, which is that we have the ability to append bytes into its buffer. Now, it's specifically FLV, Flash Video's format. So the best way to put this is that Flash plays Flash Video. Okay, it understands the Flash Video format, and actually, I'm going to not confuse it, we'll call it the Flash Video envelope for right now. That'll be my term for today. But sort of things wrapped in Flash Video, it understands. So by allowing us to go get Dash data in 264 and turning around and converting it, just a little bit of conversion and wrapping it in FLV internally, we can provide it to the Flash player, and the Flash player will render that video for us. It'll turn around and do it, which means that our implementation can be wholly focused on the Dash aspects of this, as opposed to all the other aspects for this version. So, NetStream and video classes can be manipulated. That's good. We need to. And in particular, within the Flash video world, because it's been prominent for a while, and it had been prominent for a while, there's a bunch of open source frameworks, actually. These are the two most prominent, which is Adobe's open source media framework, OSMF, and Open Video Player, and there's actually several others which are used a lot, and we see them, not to mention an infinite number of small video players and projects that are spun up inside of companies. For us, we went ahead and chose to build on OSMF. Mainly, in all honesty, partially because of the fact that OSMF is out there. You can go look at the code. You can take what we did, see how it interacts, and be able to use it as sort of a learning tool as well. Part of the goal of doing this presentation and part of the goal of doing this was demonstrating that although we're doing it for Flash right now, the actual complexity of building Dash, of doing what you need to, isn't so big that an internal video player or an internal team couldn't already support this today. This was not a huge effort to go through and do. So we sort of want to show what's going on here, and OSMF gave us the best chance to actually show because you can see end-to-end what's happening. All right, now OSMF itself, since we made that choice, is an extensible architecture. It's a plug-in architecture. Don't love everything about it. That's life. Nobody loves everything about someone else's piece of code. But it has support for DRM, some DRMs as well as being able to pass things through for Flash access. It contains classes that work with streaming technology. This is actually really important. Technically, only HDS is supported natively. So OSMF supports Adobe's protocol. Adobe's who authored OSMF. It supports Adobe's protocol natively. However, the extensible architecture makes it possible to support new technologies. We ourselves have actually implemented HLS inside of it. And as you'll see, we've implemented Dash inside of it as well. And that's because of the fact that we have this pluggable architecture which we can build things on. Here's what we need to do. And this is what our code's going to do over and over again. And this actually kind of is what we're doing, although we should talk about getting them. But really how we do Dash in Flash is that we're going to take and get these Dash segments, fragments, and then we bring them back. We're going to extract the video data, the raw video out of it. We're going to take that raw video, and we're going to wrap it inside an FLV, and then we're going to shove that FLV into a net stream. And Flash will happily go off and play it for us. So what we've done is we front-ended things with Dash. We're using Dash as our format to be able to go out and get this data, but we're actually using Flash to play it. So let's talk now about Dash and jump a little bit into this. Dash structure. There's a couple things we really have to understand. Most everything that we need to worry about actually starts with the manifest, and in fact I'd rather organize this a little differently. But the manifest, or an MPD file, is an XML file that describes the segments that we need to play. And there are many ways these segments get described, and we're going to talk about that in depth. But we have an XML file which describes the segments. We have initialization information, which is basically the headers that we need to understand and decode the bytes. And then we actually have segment files, which are where the playable media exists. These can include N video tracks and audio tracks. And actually, just an interesting side note, by the way, is that because of the fact that in this format and the way we've done things, because audio is actually sort of tracked separate than video, it means that we can actually have one video track, or we can have N video tracks at different bit rates, and potentially one audio track, or maybe two audio tracks, even though we have 20 video tracks that go with it, which compared to like pre-composed formats actually does yield quite a bit of savings in size. All right, now the Dash manifest starts out, and we're going to look at some of these in detail, but we have program info, and then we define one or more periods, okay? Most files that you'll see done in Dash right now are one period, but you can technically have more than one. A period contains an adaption set per video stream, so we'll see one per video stream and one per audio stream. And then it's all hierarchical, so inside of each adaption set, we see composition nodes for each audio and track, and then we have representations. Our representations basically describe a single bit rate, and describe one bit rate that we might have. Now, the representations are really our reference. You could think of them in some ways, and there's multiple ways this works, but you could think about them as a starting point as a URI that tells us where to find the actual segments. It describes what the segments are and where we find those segments. And then we look at different ways that we will look at different ways that segment can be described, but there's actually several. But the important thing is that we're going and getting this manifest file. This manifest file is explaining to us what segments are out there, which ones we can get, and then we're using this information to be able to continue to get things. Now, within the Dash manifest, the describing representations, there's three primary ways, and some of these there's probably about 9 ways, but there's 3 primary top ways and some variations of how we can actually describe what segments we want. There's a segment base, which is basically a way that we describe a stream. We describe an MP4 file that has a single bit rate, and it can be used for byte range requests. So technically, within this work, we have scenarios wherein we can ask for a byte range out of an MP4 file. In other words, please give me this segment as a byte range. Or we can individually store the different fragments as individual files. There's 2 different reasons that one would approach this. The one that is probably most resonant is it's the old trade-off of memory versus CPU. When we have a segment-based scenario where we have a single MP4 file, and that single MP4 file contains all the data and we index into it, it does take work, it does take processor time to go when somebody makes a request, get the data we want out of this larger file and return it. When we expand those files already, when they're already in a directory as individual files, it's much quicker for a web server to return them, but it's going to take up more storage space. So you'd think in these days and times that storage space is relatively cheap and you'd always expand it. And in fact, most of our clients do. They leave things expanded. But the interesting thing is that, let's say we have a video which is, I don't know, older, rarely accessed, things like that. For those, we may want to take the trade-off and say, let's keep it as a single MP4 and index into it, because it's not hit very often. And we don't want to deal with storage and backup space, because again, everything has additional costs, and when you talk about storage space, you talk about backup space, and when you talk about all these sorts of things, and migration space. So segment base, and I guess this is my general point on all of this, is that Dash is intended to be very flexible, and that's why we're going to see a lot of these different ways of doing things. So it's already building in the ability to manage your files and manage things in different ways that you want to. Now, by far, in my opinion, at least the ones we've seen so far, some of the more common are segment lists and segment templates. Lists and templates actually allow us to have a more linear approach to things. But let's look at each of these together. So I mentioned a segment base here. Let me grab my segment base example. This is a manifest file which actually uses a segment base. So as I mentioned here, going back, what we'd see is that we'd see a manifest containing program info, a period, an adaption set, and then a representation. And we can see that here. Here's our main file where we'll see things like our times and our minimum buffer times, and we'll talk about profiles in a bit, what profiles are acceptable. We get a period, we get an adaption set, and down here we have our representation. So here's our representation for one bandwidth, here's our representation for another. We specify what codecs, heights, all this sorts of MIME type information, and then we see, in this case, because of the fact that it's a segment base, we see an initialization range. In other words, this is the range where all the header information is going to be contained, the range where we're going to be able to do things. And let me actually, if I can, real quickly on this, sorry. Let me just up this a little bit. Okay, so within segment base, we see an index range. In other words, these are the valid indexes we can ask for inside of that MP4 file. Here is where the information exists as far as our initialization range. And we see this for each one of the different bandwidths that, or bit rates that we want to be able to provide. So this is what a segment base scenario for being able to define segments looks like. Again, trade-off here, more CPU, less physical storage. This is one way that we go about doing it. Incidentally, in the Flash version, you'll see a little bit of a change here. Flash actually, for several ways they've decided to approach security, limits the way that you can actually tweak or deal with headers and what you can do. And technically, you're supposed to provide the segment-seeking information inside the headers. So in a Flash version of this, you can't quite do it to the standard. You actually have to make a few tweaks, but not relevant at the moment. All right, the next thing we want to see is a segment list example. Now, in a segment list example, we basically have a list of where the individual packets are and the byte ranges associated with them. Okay? So when we go into a segment list example, what we actually see is something much more like this. So same ideas, period, representation. And within our representation here we have a low rep. What we have is a URL of sequential segments that are going to be retrieved in order to provide this information. So we'll be getting those sequentially, just using this really as an iterable list that we go through, loading each and every one of those as they're needed in order to play things. Now, we'll talk about the mechanism of it, but you can imagine that the core mechanism is at some point the player is going to say, hey, I need you to start bringing down the next segment, and we're going to refer to this list to know where that next segment comes from. It's very, very flexible and easy to understand this format. It's a list, but for very long-running content, this list can get quite long, especially depending on what size of your fragments are. A little thing here you can see up front is that we have a duration and we have a time scale. The duration divided by the time scale is kind of your length and time, so this is 10 seconds or whatever the case might be. But for something that's particularly long for every the total play length, not the individual fragment length. That's the fragment length, or how long each one of those fragments is. But something that's particularly long, divided into 10-second fragments, could be a lot of entries into this file. And it could mean that your starting point where you have to download this fragment is actually a bit of an endurance effort to begin with, just to get down and parse this information before you can begin streaming any video. So this is the segment list approach to the manifest. Now, lastly, most complicated but also most interesting is the segment template. Now, segment template works on more of a templating engine idea. So we have a known URL with wildcards. And there's also a variation of this that we can sort of talk about as far as segment timeline. So let's look at one of those really quickly. The simplest one over here is this one. And the segment template here, again, we're still defining the same basic Ps, program information, period, adaption set. When we get down to a representation, we'll see a segment template. And if I come over here, our segment template defines something that looks like this. Let's see if we can get it all on the screen. We're going to get Big Buck Bunny, 720p. We've encoded, in this case, by the way, this particular encoding only actually has 1 bit rate. So that bit rate is hard-coded in here. And so is the audio. But then what we'll see variable and number substitution. So in this case, we have number in $signs. What that's going to be is that it's going to use this same URL pattern and simply increment the index as it continues. The incremented index basically tells it where to get the next segment. So in this case, we've had to name the segments by convention and then set up a template. But as you can see, this entire manifest file for this movie was 21 lines long, versus when I went to a relatively short segment list, we have 415 lines of manifest there. So segment templates, especially in a basic sense, can be very, very interesting in how one actually pulls things, but it requires sort of a periodic approach. We have to know we have 10-second segments or fragments, and we're going to load these in order, and the URL scheme is going to work to this degree. But it's actually, to me, one of the more interesting and simplified approaches of doing things. Now, there's nothing that can't be complicated, so we can also look at segment template, but used in a timeline manner. Now, within here, our segment template now will specify something like bandwidth and time. So these are other replaceable strings that we can do within the URL. So same idea. It's still a segment template. That segment template has more variables than just the number. The number is an index-based one. Here, we're actually doing things based on time. So what we'll see below now is that there's a segment timeline. Starting at time offset 0, the duration of the first segment is this long. The duration of the next segment is this long segment, and it's giving us basically time durations for each one of those segments. That allows us to have variably sized fragments that we can actually load in segments that we bring in. So we can have variable sized ones. There may be different reasons for doing that. Oftentimes, to be honest, in this, you might see two definitions in here, one for the entire first length of the movie, and then one for the very last bit, which happened to not fall on a border. That's pretty common. But what we'll see is we'll see durations in here, and there's a couple other things that get a little more confusing. I think there's an example in this one. Let's find out. There's an R in here somewhere. I know there is. Well, that didn't help. There we go. R, which basically means that this particular duration repeats twice. So there's complexity to this format, but still viable. It's still less data than we actually have with a segment list. We're still basically doing things now based on time as opposed to just the raw indexing of what comes next, what goes forward. But those are, I think we showed 4, and I think if you count like the variations and look at it factorially, it's more like 9 possible kind of combinations of how these pieces come together. The point here, though, was in going through all these was both to give you some familiarity with what that MPD was, but also in the sense that there's enough flexibility built into what's in Dash and which is in the specification to basically allow for anything we want. If you go back to that page, or if we were to look back at the vendor page of people on the industry forum, we're working with a lot of them already to validate our stream, or that our ability to play different streams. And we have not encountered 2 companies yet who have encoded their stuff exactly the same way in Dash, and that's all right. The cool thing is that there's the flexibility to be able to do it for what makes sense on a business decision, what makes the most sense for the content, media, things that you're doing. By the way, audio, video, any type of adaptation set can be encoded this way. So in this particular one, you'll actually see that, let's see, the first thing that we're actually encoding here is audio. So this was audio MP4 as the first adaptation set, and then when we get down to the second adaptation set, we're actually seeing the video segment down here in group 2, and the bandwidth and associated information with it. Okay. We doing okay so far? Yes. The audio stream and video stream can come down separately and are coordinated. The idea with a lot of these pieces, and especially we can kind of see it here actually. So if we see the adaptation set for video and we look at the segment template, we have 18-video is the file name. And if we go back up here for audio, we'll actually see it's an 18-audio. So we'll actually have separate files for both the audio and video piece there. So one of the interesting things to me about the whole MP4 idea, too, is the idea of composition as opposed to pre-composition, but sort of runtime composition, where we can actually do many more things and repurpose content in new ways because of the fact that we don't necessarily have to pre-compose. Yeah, go ahead. Yeah, most of these things you'll see when we look at durations and time codes, it kind of understands where it starts as a time code and where offsets happen and where synchronization has to happen. That's part of it. And if you want to do any more with that, I can probably answer a little bit more detail, but I might refer you to somebody else too if you want to get into the depths of it, especially into those parts. But the idea, though, of any sort of runtime composed format is the idea that, again, it can be recomposed later, right? If I were to compose an audio track right in and it was part of the same stream as the video, that's sort of a fixed element. They're coupled together. Now, we can, inside the format, still keep them somewhat separate in a binary way so that they're separable. But the interesting thing here is that you can imagine adding extra audio tracks or adding things to them is quite literally defining a different MPD file, potentially for the same video. Some complexity there, but to talk about it. Anyway, there's just some interesting possibilities in how this all comes together. Okay, so that gives an idea of describing these representations of how things come together. Now, within that, we kind of said these, but I actually preferred, rather than looking at them as slides, to talk about them. But again, a couple things to look at. Each of these segments in this case was going to have a length. That segment length is defined by really the duration and the time scale. Most of the time, this time scale is 1 second, and so a 10-second segment duration. In this case, each one of those URLs represents 10 seconds. And really, by the way, when we talk about upshifting and downshifting, it's quite easy in the sense that what we do is we know a bit rate, we know what segment we have to download, and we know the time it took us to download something. So if we know we can't download that segment fast enough in order to keep up the bit rate we know we have to go to a different bit rate if it's available. And some of the different sample movies we'll show at the end, some just have 1 bit rate. I thought we were going to be in trouble. The wireless here was not is not doing great on being able to download some of these things. I actually went to speed test briefly, and it failed rather than run a test, which I thought we were in a whole lot of trouble. But fortunately, I'm wired now, so we'll be able to show a couple of the examples. And we won't have any bandwidth problems here, but I can simulate a downshift, so we can talk about that. All right, so again, segment list is just a linear list of all the segments, what actually happens. And segment template on the other side is actually showing a replacement, so being able to do templating. Segment templates tend to be smaller manifest files, especially in the simpler cases. And then variable length segment duration. So this is us using a segment timeline. It's a great question. If you don't mind, grab me afterwards, and I'll get you the right person for that. I know the pass-through DRM stuff, but I don't know exactly how it codes into here. All right. So really quickly, and this is basics. We aren't going to dive too far into this, but when we look at an MP4, or especially H.264 structure, and this is relevant to what we're about to do as far as, well, not parsing it apart really, but breaking it apart in a binary way. We've got a bunch of segments that are binary. They're a series of boxes. Okay. There are a large number of boxes. We actually deal with most of them right now in even our prototype player. But there's a large number of boxes. The very first thing we do is you can think of a box as just a binary blob. The first 8 bytes of that binary blob define both the box type, so one of n types that we're going to represent, as well as a number of bytes that are actually in that box so that we know how to read it and parse it. It's not technically parse, but process it. There's a few things we want to get out of here. First of all, file type, compatibility. There's some free space we skip. But then we get into some interesting things which are really relevant to us. The move, which is a container for all metadata, header, and then track information. Okay? This track information gives headers and containers for all of that, for those boxes. More importantly, though, for us, when we try to get down here, is we're getting segment type and index and movie fragments. What we really wanted to get to is here. Now, we need all this information to reconstruct. We need this for timing and for many other things. But MDAT, the media data container, this is actually, at the end of the day, the smallest describable piece of content. It's a sample, okay? It's an individual sample of data, of video data. Now, for us, a sample is the smallest piece that can be wrapped and given to the Flash player to play as one sample. So this is really relevant to us because we're diving down in this video data. We're trying to grab this 264 data, and we're grabbing a sample at a time so that we can take that sample and turn around and be able to hand it off to the Flash player. Now, what we're doing here is we're working with OSMF. So for a moment, going back, OSMF is this framework which allows us to hook in very specific places. And in order to make this work here, we had to hook into 2 interesting places. OSMF has an idea of index handlers and file handlers. Index handlers, put short, are basically deciding what the next URL is. So when it's time to get another segment, which one do I get? The index handler's job is to figure out what's the next handler that I need. What do I have to go off and do? And by the way, different versions of the stuff we're doing are modeled in the same way. Just a little side note for people who I know happen to be interested in other versions. But we have an index handler, and the index handler's job is decide what the next segment is. How does it decide? Well, based on a whole bunch of things. Like you saw those templates. It's building out lists of what it needs to do. The file handler is actually responsible for taking that data and returning FLV. So if you can picture OSMF as sort of this big box over here that's doing the work, it's handing off something to us and saying, I need the next segment. And the return from the index handler is basically a URL. What should I load next? OSMF loads it, and then it calls off to the file handler and says, I got this data for you. Do something with it and give me back some FLV. And so the file handler unboxes things, gets them together, prepares it as an FLV, or prepares a sample as an FLV, and shoves it back in order to go into OSMF. Now, ours are called dash index handler, right? So there's a couple things in here. We have a get next file method. We have a get file for time, depending on those 2 formats I already showed you. Because sometimes we have index-based things, sometimes we have time-based things. So it's going to go off and it's going to figure out what the appropriate URL is based on having already parsed that manifest file, understanding what format it was. And then these things are going to be called. All right? In either case, we're going to take that stream request, which then OSMF, it's really a kind of a wrapped URL, OSMF uses to actually go off and get the proper segment. And as I mentioned, when we come back, we actually go ahead and we decode it, right? Now, we're using an MP4 decoder to basically break apart those boxes. That's part of what we need to do. And then we're trying to eventually get the FLV bytes, or wrapping the FLV bytes inside the MDAT. In Flash parlance, there's a byte array. A byte array is basically a way to look at represent arbitrary binary data. So what we're really doing here is we're processing this data and we're putting it into a big old array of bytes, and then those bytes are returned. They're converted to FLV, and they're added to the netstream buffer. Now, OSMF does the final step, but that final step, which actually makes this all possible, is that Flash has a simple method called append bytes. And what append bytes really does is it says, hey, you know that video stream you're playing now, take these raw bytes and throw it on the end of it and just keep playing. That's what actually makes this whole thing possible. And by the way, when we get to browser stuff, that's what makes it possible to do this stuff in certain browsers right now, is when we have a very similar capability. Okay. So MP4 decoder gets through boxes. For the most part, the nuance of this isn't as important as the fact that we really can get individual samples out of the MDAT. And an MDAT, keep in mind, any one of those MDAT boxes actually does contain multiple samples potentially. But we're wrapping individual ones as FLV bytes and sending them on. All right. That said, what that does is it throws us to this place where we'll do a little sample based on where it's at. Now, incidentally, this is all being shown for two things. We're using this Dash player for our clients, and that's fine. For us, we actually started with doing this is to understand Dash. We tend to do things like this as a company, where we take R&D time. It's like we want to learn this concept better, so fine, allocate R&D time, go build it, learn it, figure out how it works, and put it out there. So right now, this thing isn't commercially available out there. However, the pieces that are associated with it, odds that they are available both in an open and other licenses for people in the very near future is extraordinarily high. What I'll say for right now. So if we look at this right now, we support SegmentList, templates, base, manifests, dynamic adaptive streaming for VOD streams. In fact, honestly, at this point, we actually do support live as well on the last build. We can actually run 1080p streams through this, and quite well. And we've actually tested this with several different encoders from a lot of companies in the industry forum that are working with it. And we have not only a desktop version, but we are optimizing at the moment a very, very nice mobile version that works quite well as well. All right, really quick things on this, and this is more about what doesn't work, to be honest, is we have some fixing things to make better, multi-channel audio support, better support for live streams. We do actually have it, the basics now. And there's continued to things as we continue to get streams from other encoding partners. Here's the other interesting things, though, and I want to talk about this for a moment. This wasn't our end-all, be-all. Our goal wasn't to make a Dash player for Flash. Our goal was to be able to do a Dash player, which was the beginning of something bigger. So one of the things that's in active development right now is a JavaScript version of this Dash player. First target's Chrome. That's actually being written as the reference player for the Dash industry forum. So all of the code will be open from that JavaScript player and put online. The really cool thing is that at least for today in Chrome and some other browsers following close behind, you can drop this little chunk of code in a page and actually have a full Dash video experience, which is pretty cool. DASH-264 specifically, video experience. In addition to that, we're working on DRM, some enhanced seeking, some other pieces. And then the two last little things out here that I'll throw out are that there's actually both an Android library and an iOS library in the works to be able to handle this, so that from both the Android and iOS libraries, one can go off and actually get this sort of Dash stuff. The iOS one, because of licensing and some other things, provides some unique challenges, but we can talk about that another time. All right, so the idea behind this is that the stuff you're about to see is an entry point. It's an entry point into it, and a starting with Flash because it was the easiest and most set up format for us to do and the most ubiquitous for us to target. But it's really the idea behind Dash that we're after and what we're trying to do here. So, that said, let's take a look at a couple things here. A few pieces. Let's go to Dash test. Make sure I'm still good. Okay, so we can start with some basic things here, which are kind of cool, or basic. Right now we're set to do auto bit rate, okay? And so we're doing about 25 frames per second here at the moment. We can actually do better than that. But you can see down here that this current resolution is 1920 by 1080. Now, we have plenty of resolution, or plenty of bandwidth. So this thing has no need right now to be able to drop. But if we turn off the auto bit rate stuff and we say down, it's going to go to switch in progress. And what's going to happen now is when it expires its current buffer of what it actually has built up, and I should have switched it a little sooner to make sure the buffer was smaller. But when it actually expires that buffer, it's going to downshift into a lower resolution version of the stream, a lower bitrate version of the stream, and it should be there in a second. Come on. Or I'll restart it and do it right away. Waiting sucks when you're on stage. All right, watch this. This time we'll do it and I won't talk through the whole beginning of it. The point of it is that if we go in and turn off this thing right away, we'll go in and not let it buffer up this time. We'll turn off auto bitrate as soon as it starts playing, and we'll say down. And what we should see is we'll see it drop from 1920. And we'll see switch in progress go away. And so now we've switched down to 1280, and if I did it again, when the buffer expires, it'll go down to the next available one. But it's actually doing that on the fragment borders and the selection. And this is the logic by which it does this automatically and very smoothly in the background, because it's being able to pick up things on fragment borders. Again, all of these fragments have been encoded in such a way that regardless of the actual bit rate, they're falling at the same time codes on the same pieces. So I can make a decision arbitrarily in the stream to stop working on a certain bit rate stream and to go out and pick on a lower one or a higher one. If, in the decision logic, we have a really simple rules engine to do it, but the simple logic is if I have more than enough bandwidth to be able to download what I need to download in a fraction of the time I have available in a frame, then go ahead and go up bandwidth. If not, go down. But we can do auto bit rate. Obviously, we can also do things that are a little nicer than that, or at least as a starting point. Yeah? Absolutely, and that's the cool thing about externalizing this into a rules engine, is that our implementation can actually be quite simple, but we encourage the idea that people can individually tweak that. So our first implementation is really, really simple, and that's kind of my guide. But the idea is to start it out with something that somebody can easily understand, and then be able to have more complicated versions of that as we go along. This is 720p right now, streamed through the same thing, and even with our bandwidth, looks pretty good as we're able to come through. These are, it's not bad, the latency in the projection. But these, again, are all these same streams, and all we're doing, again, is processing the dash headers to be able to do it. In fact, honestly, just as a side note, some of these pieces I was showing, when I go back to the basic, this is actually the Big Buck Bunny MPD file. So it happens to be one that's using segment template. Which one was it? I think it was, yeah, back here. Yeah, this was the GPAC one. So this segment URL list was actually that first one we saw. And then there's a couple other ones here. But these are actually showing the different formats and the different types that we actually support as it's going through. There's a 18 trailer I technically probably shouldn't play. I think I'm probably violating some federal rule. Let's see if that's up. Some of these are coming off of sources that may or may not be up. Oh, so right now I have this shifted way down because I don't have auto bitrate on. Let's go ahead and turn that back on. We'll let it recover when it gets to a chance. And then we'll actually pick one last here, which is coming off of Akamai, and this is actually using, by the way, if you saw it in the background there, it just switched up bitrate because it knew it had plenty of bandwidth, which is why it got better. And then finally, we'll actually go through and we'll play a byte range one. So this is actually coming off of Akamai's servers, and this is actually using byte range requests. So here, we're looking at one static MP4 file that's actually listed on the server, and that on those individual portions, based on our bandwidth, based on our availability of what we can do, we can go forward. So here we actually have, if you'll notice, it says it has 5 streams available. It's currently playing the highest bandwidth one, and we can go up and down, but it's requesting those statically from that MP4 file with byte range information right now. So that's how this one works. And the MPD file for this particular one was, I'm pretty sure, this one. Let's see. No, that's A-Team. It was a segment base, right? Yeah, I'm pretty sure this is actually the one. Yeah, so this is the one for that video that's was playing in the background right now. So right now with this demo, it's working with byte range across one ISP and only with one service provider. But the interesting thing about it is because of the fact that there is no context to the request, right? And I'm sorry, let me repeat the question, at least if I understood it correctly. The real question is, you know, in this scenario where we're doing byte ranges, you know, if we're going across multiple ISPs or multiple CDNs or whatever the case is, how does that work? The interesting thing about it is that it doesn't much matter in this format, and that's why it's so nice. Because when we're streaming things, we don't care where we get the next fragment from. Because as long as we're deployed and each one of these is a simple GET request, we can pick up fragment A from here and B from here and C from here. We don't have to maintain any type of connection. And that's, again, going back to what I was saying, is that we can actually use optimization and all these sorts of things that the internet was intended to do to route us to the most viable potential piece. So since the byte range requests are going to be the same, so long as the same MP4 file is deployed everywhere, to all places that we can hit, and if it's not, that is a separate problem outside of playback. It doesn't matter if we pick up from CDN A or CDN B that same byte range request or who gets the next one. We can dynamically pick, we can be routed, we can be aware or unaware of it. We could rotate through on the play side between different areas in order to do some primitive sort of optimization, or again, we can just let the network infrastructure return what it will, and who knows what server we got it from, so long as we actually get that back in a timely manner. So you said you had some issues with the browser dropping? Right. So don't get me wrong. Whenever there's a network infrastructure issue, it's obviously going to impact something on the application layer. And there's some things, but little the application layer can do about that. But in general, it's not necessarily the idea behind Dash or the idea behind this that's the problem. What you're assuming is a more or less properly working infrastructure. Now, even in this player, if there is actually an error returned, so in other words, something is off and we go to try and make a request and it turns out that request cannot be fulfilled, the player itself will automatically retry and go off and try and get that segment. That is, by the way, in this sort of format about the only time you actually get, the only two times you can really get a hiccup in a downshift, that sort of repausing, rebuffering scenario, is two times. Number one, when you actually have a dramatic bandwidth loss and or the bandwidth is simply so low that you can't keep up with even the lowest rate bit stream. Or the second scenario is when, for instance, there's a network interruption and we have repeated requests to try and get the same fragment and we can't get it. But those are about the only two times, and that's one of the more interesting things about any type of this client-side streaming, is that the number of times we actually see those sort of initial buffering screens and those pauses in between go down dramatically. I have lots of metaphors that roll through my head, but it's sort of that shower scenario. It's, you have the shower on and someone flushes the toilet. The pressure imbalance of who's using hot and who's using cold changes the stream, what's coming out. There's different ways to handle that. In the default way, you allow the temperature to change, but there are devices you can actually install as part of plumbing that say, no, when the pressure of one drops, drop the other pressure equally to keep things the same. It's kind of the same thing here. Traditional streaming has said, well, we have one connection, we have one stream, so unless we're actually going to connect to a new stream, if buffering slows down, we try to send less, we try and do different things. Here, the idea is more along the lines of, great, the next time I need something, go grab it, go grab a different one. Just acknowledge at those fragment levels that I can grab something completely different. Yeah, in fact, actually, as far as going through, in fact, even I don't know if you saw it, in the course of doing Big Buck there was actually a drop frame count. And one or two drop frames were actually happening in that exact same scenario. So there was one or two times that it simply wasn't either viable CPU-wise or something else to play that frame anymore in the course of it, so it dropped and it kept going. So in this case, it's Flash that's doing that work. We're basically grabbing these things and we're packaging them up and we're handing them off. We're allowing Flash to actually do that work, right? So we're not a player per se. What we really are is we're something that understands Dash. We're something in front of it that understands Dash, understands the MPD, understands how to go get those fragments, package them up in such a way that Flash player understands how to use them and hand them back. So it's not fair to call it really a player. We're a piece of a player. Fair? And is given, right. And right, but I just wanted to make sure it was clear that we're not doing 264 or something in here. We're not doing anything. We don't have an implementation of a codec in here. We're simply getting that data, packaging up for Flash, and giving it back. Say again? Yeah, honestly, some of those things work already. We actually have. In lower bandwidth scenarios already, we're accurate enough to be able to seek and do fast forward or rewind or things that we need to. In higher bandwidth scenarios, this particular player still has a problem, but all viable. Sure. So right now we're still in this version, we're still downloading everything. Whether that stays that way is probably, as it continues to evolve, will change. But right now, there's no change in what we download based on going fast forward or reverse. Sure.
or drag the bar somewhere.
Got it. Right now, this particular player is caching anything that it holds onto. So once it's brought down, it's actually caching and it's not going back out. However, there's two interesting things about that. Number one, we're choosing to cache in memory right now because we were taking our first stab. But the interesting thing is about fragments downloaded this way is they can also be cached by the browser. So when we do go back and forth, we can also pick them up out of a browser cache as opposed to even if we didn't want to application cache them. It's not quite as fast, but it's also not really going to the network even to get those fragments again. Okay. Well, thank you all for your time. I think the only other things that I put up here is that if you were going to explore a little bit more, the major things that we found that being very, very useful is the GPAC stuff, which is great because not only do they have some baseline pieces, they have some fantastic test streams that we can use and work with. The MP4 parser project, there is a Java project out there, which is great. It's a wonderful piece of code and well documented if you want to understand more about the MP4 format. And obviously, the Dash Industry Forum is something that we well support and believe in. So we want to go from there. Other than that, I hope you enjoy your lunch and the rest of your day, and thank you very much.